Next, we're going to take a look at two variations with these laws of exponents. We have our four laws. We're not going to add any more laws, but I just want to show you two applications of things that we can do with our laws of exponents. And the first is what happens if we have multiple terms. Take a look at this example over here. And notice, unlike the other problems we've dealt with, we have a plus in the middle, which means I have two separate terms here. I have 2a cubed times 3a to the fourth, and then I have 2a to the fourth times 3a in parentheses cubed. So I need to try to simplify this thing. Well, the way we're going to do this is we're going to simplify the first term, we're going to simplify the second term, and then sort of see where we end up. Over here I can do 2 times 3 and get 6. a to the third times a to the fourth, and get a to the seventh. I'll write that plus in between them. As for the second term, well, it's going to take me 2 steps to do this. I'm going to say 2a to the fourth times 3 cubed is 27 a to the third. Cleaning that up a little bit more, I'm going to get 6a to the seventh plus 2 times 27 is 54 a to the seventh. And now, what we should notice is these are like terms. To be like terms, we have to have the same variable with the same exponent. And if we have like terms, we're allowed to combine them. I've got 6 of these and 54 of those, which means altogether I've got 60 of those same things. I'm not going to change my variable or the power. I'm just going to combine them and get 60 a to the fourth. What we need to do when we have multiple terms is first simplify each term. Then, if we have like terms, same variables with the same exponents, we can combine them. If we have like terms, same exponents on the same variables, we'll combine. And when we combine like terms, don't change the powers. So please take a moment and get those copied down. So let's take a look at a few examples of these. Can you please simplify the first term and simplify the second term? Then together we'll see if we have like terms. If so, we'll combine them. If not, we're just going to be done. Take a moment, see what you can do. Two a to the fourth times 9a squared b squared minus, 2 squared is 4, b squared times 27 a to the sixth. Let's do our multiplication, and we're going to get 18 a to the sixth b squared minus 108 a to the sixth b squared. They are like terms. I have the same variables with the same exponents. So I can go further. I've got 18 of those things minus 108 of those things. I'm left with 18 minus 108, that's negative 90. Of those same things of a to the sixth, b to the second. I'm going to get negative 90, a to the sixth, b to the second. Try letter B. Simplify the two terms, and together we'll decide if they're like terms or not. Try letter B. Okay, so this first term is 2ab squared times 64a to the third, b to the third. Next term is 3a to the fifth b times 9. I don't really know why I did that. I just rewrote the problem, I guess. We're going to get 128 a to the fourth, b to the fifth, plus 27, a to the fifth, b to the fifth. Oh, wait a minute. Nope, I think I'm good. Are these like terms? They are not like terms because the b's are okay, but the a's aren't. I would need both variables to have the same exponents, and I don't over there. So what's my final answer? That's my final answer. I'm not allowed to go further. See if you can do letter C on your own. And I guess I could have just started by multiplying them, but whatever. I'm going to distribute the exponents to the second piece. First term is going to become 6, a to the third, x to the fourth, minus 216, a to the third, x to the fourth. Yep, they're like terms. I can go subtract, and I'm going to get negative 210, a to the third, x to the fourth. So this is what happens when we have multiple terms. Things that we're like adding or subtracting, we'll just simplify each term. Then if they're like terms, combine them. If not, we're done. Next thing I want to show you is how to simplify certain types of fractions, like x squared plus x to the fourth divided by x. What we're going to do is called separating the fraction, which I'm always allowed to do if there's a sum or difference in the numerator, but a single term in the denominator. X squared plus x to the fourth over x is the same as saying x squared over x plus x to the fourth over x. I'm just going to separate my fraction and divide both of those things in the numerator, both of those terms in the numerator, by what I have in the denominator. Well, x squared divided by x, that's just going to give me x. X to the fourth divided by x, that's going to give me x to the third. I'm getting x plus x to the third. They are not like terms. You can't go further, so that's the final answer. We're going to start by separating our fraction by dividing both or any term that we have in the numerator by the denominator. We'll simplify, and then we'll see what we're left with. Next one, we have 15m over 15 plus 15n over 15. You go finish that off and send the answer into Edpuzzle. This is just m plus n. Done. Letter B is a little bit more involved. In letter B, 18r s to the third over 9r squared s squared plus 27r squared s to the fifth over 9r squared s squared. That's my first step of separating the fraction. You see if you can go from there. Looks like 2r squared s plus 3 s to the third. Okay, one more. See if you can do letter C. So my first step is I'm going to go and I'm going to separate my fraction. (48 over negative 8 is negative 6. X to the sixth on the top, y on the top. The double negatives are going to make this a plus, so I'm going to say plus 4 x squared y to the sixth with a z over there. Next time we will look at 2 more laws of exponents and kind of round out this first section.